Good day, everyone. We are the Group 2. I am the first speaker of today. I am Cadet Raimonia Bapulanyas, and member is De Cadet Igamo, De Cadet Ibarle, De Cadet Iborda, De Cadet Irino, De Cadet Garbosa, De Cadet Gidokyo, De Cadet Intoy, De Cadet Inutan. So our topic today is all about the importance of ship's turning circle in ship handling. So the circle is the path of the ship, pivot point as it executes as 360 degrees turn. In shallow water, the rate of turn is likely to be decreased, so the vessel will have larger turning circle. So it's very important of turning circle, and to stopping the distance and speed trials provides essential information to those that control today's ship. So the next speaker is De Cadet Digamo.
Good day, I'm the Cadet Bigamo Chris Lawrence, and I'm here to discuss the slide 3 and 4. So, once trials of a new ship are complete, operators will need to know how the vessel can expect to perform in a variety of sea conditions. The ship handler, for instance, should be aware of how long it will take for a vessel to become stopped in the water from a full ahead position, or how far the vessel will advance in a turn. So, turning circles and stopping distance provides such essential information to those that control today's ships. Merchant ships usually turn in a circle having a diameter of about 3 to 4 times the length between perpendiculars, so what we call LBP. The larger the rudder, the smaller will be the turning circle diameter, or what we call TCD. During the TCD maneuver, the ship will experience transfer, advance, drift angles, and angle of heel. So that's all. I will give it to the next reporter. Thank you.
Hi, I am the Cadet Ibarli, so I am here to report about the slide 5. So, advance. What is advance? Advance is defined by the forward motion of the ship from the moment that the vessel commences the turn. It is the distance traveled by the vessel in the direction of the original course from commencing the turn to completing the turn. It is calibrated between the course heading when commencing the turn to when the vessel head passed through 90 degrees. Next is transfer. Transfer is defined by the distance which the vessel will move perpendicular to the fore and aft line from the commencement of the turn. The total transfer experienced during a turn will be reflected when the ship's head has moved through a course heading of 180 degrees. The amount of transfer can be calibrated against the ship's change of heading and is usually noted 90 degrees and 180 degrees. So, tactical diameter. Tactical diameter is defined by the greatest diameter subscribed by the vessel from commencing the turn to completing the turn. When the vessel is trimmed by the stern, the tactical diameter of turn is increased. When the vessel is trimmed by the head, the tactical diameter of turn is decreased. The vessel with the least will take longer to execute the turn, and when turned into the least will develop a large circle. The vessel with a right-hand turn propeller, if making a turn to port, will end up with a smaller diameter than starboard due to the effect of transverse thrust. So, next reporter of slide 6.
Hello, I'm Decadet Iborda. So, next is the final diameter. It is defined as the internal diameter of the turning circle where no allowance has been made for the decreasing curvature as experienced with the tactical diameter. So you can see in the illustration the final diameter. Next is the drift angle. It is the angle between the axis of a ship when turning and the tangent to the path on which it is turning. Next is the factors affecting turning circle of ships. First is the draught and trim. Next is the distribution and stowage of cargo. Next is even keel or listed. Next is rudder angle, available depth of water, drift angle and influencing forces, and lastly, the structural design and length.
I'm Cadet Mark Vincent De Reno. The way to get started is to quiet talking and begin doing. Walt Disney. Compare the turning circle is ballasted condition to the turning circle is loaded condition. This maneuver is carried out with the ship at full speed and rudder held set at 35 degrees. The ship is turned completely through 360 with say starboard rudder held and then port rudder held. See the figure picture. TDC or tactical diameter transfer, maximum advance, maximum transfer, drift angle, path of ship, center of the gravity. Note the initial movement to starboard. Then advance, as you can see, there's a way to turn to 90 degrees to 180 degrees until you get the 360.
Good day everyone, I'm the Cadet Channel Docu. My topic is about the normal fall loaded condition with maximum rudder angle. Full sea speed 104 npm. Meters, transfer diameters 0.411 in miles, and starboard side is transfer diameter 0.54 in miles. So port side 15.9 knots and 2 seconds 06 degree, and about starboard side is 17.0 knots 2 seconds and 07 degree. Then port side 11.5 knots and 4 seconds and 10 minutes, and 12.2 knots and 4 seconds and 11 minutes. 9 points and port side 9.7 knots and 5.5 seconds and 19 degree, and 11.34 knots and 6 seconds and 24 minutes. So the both side of port side and starboard is the same, 25.52 knots, and starboard side is 25.52 knots. So same response.
Good day, sir. I'm Cadet Garbosa, and today I'll report the slide 11, the normal ballast condition with maximum rudder angle. The full sea speed is 104 rpm. The transfer diameter of port side is 0.568 nautical miles, and for the starboard side is 0.581 nautical miles. So as you can see here, the port side have 16.9 knots, 1 degree and 24 minutes, and 12.8 knots have 3 degree and 23 minutes, and then 11.1 knots have 5 degree and 8 minutes. For the starboard side is 16.8 knots have 1 degree and 43 minutes, and 13.4 knots have 3 degree and 24 minutes, and the last is 12.8 knots, have 5 degree and 10 minutes. So for the both port side and starboard side have 26.1 knots. And then the advance of port side is 0.488 nautical miles, and then for the starboard side advance is 0.486 nautical miles. So the turning circle, normal ballast condition with maximum rudder angle, full ahead RPM. That's all, sir. Thank you.
Good day, I am Dick Cadet Wilbur Z. So this video explaining the half ahead turning circle. So in this figure, as we can see, the form of port side and starboard side are the same, and the use the nut are same, but in demo they are different nuts they use, but in the end the position are the same. So the port side use 30.05 knots to go forward, and the starboard are same 13.05 knots. So but if they move, the nuts are different apart by port side and starboard side, but in the end they are the same position. So this is the figure of turning circle, normal ballast condition with maximum rudder angle half ahead RPM. This is all about half ahead turning circle. Thank you. Next is Inotan.
Good morning, my name is Cadet Inutan Orle Lorenz, and I am here to present slide number 13, or turning circle with normal ballast condition with maximum rudder angle and half ahead RPM. As you can see here in the slide, half ahead 53 revolutions per minute RPM. The tactical diameter in starboard side is 0.52 nautical miles, when port side is 0.582 miles. As you can see here in the turning circle, approaching turning circle, is the speed became 8.9 knots, as to comparison to the port side is 9.02 knots, which is the port side has much larger speed but smaller turning angle, only 2 degrees and 52 seconds, compared to starboard side is 2 minutes and 54 seconds. Also here in half turning point, so you can say that the starboard side is also has much larger speed, 7.8 knots comparison to 7.6 knots, and has a much larger turning angle, 5 minutes and 45 seconds compared to 5 minutes and 43 seconds. So in the halfway point, 7.7 knots comparison to 6.8 knots on the port side, and the starboard side has a much larger turning angle, 8 minutes and 44 seconds compared to 8 minutes and 41 seconds. They have the same speed, 13.05 knots. So the advance, as you can see here, the advance is 0.463 nautical miles compared to the port side 0.460 nautical miles. So if you compare it, the starboard side has much larger angles. As you can compare it with the previous slide, the advance is much greater than the normal ballast condition with maximum rudder angle, half ahead RPM. So also, if you compare the turning angle, you can see the difference if you have a much larger speed. And that would be all for my report. Thank you.
Give a damn about a hater when I feel like it. Not today, not today.